Okay, so looks like a couple of radiological survey meters here. Radiacs. Nope, only one is. I showed it before in a previous video I've posted. That would be the one on the right, the Victorine, with pancake probe Geiger counter. The one on the left used to be a survey meter. I gutted it, used the chassis and things for a different purpose, which you might find interesting. So let me get rid of the Radiac probe and have a look at what this other box now does. That's the probe, the Geiger Mueller tube pancake probe setting aside. I'm going to keep him here because, again, there's a handy holder for other miscellaneous probes. In the case here, this one. This is not a Geiger Mueller tube. It's a sort of a microphone. So I'm going to snap him down in here and set him back. Now, this used to be an ion chamber, civil defense type meter. I painted it gray because I hated the yellow. Of course, I left the handle yellow. It's got some different electronics in it now. What used to be a analog meter, the readout, is now a speaker grill, and there's a speaker behind there, a little 3-inch speaker, just under a watt of audio. Range switch, power pilot, LED, a couple of knobs we'll get into later, and some ports. One is input, 2 of them are outputs. This is now a batcall detector, and by bat I mean bats, the ones that fly, not the ones that smack baseballs about. This, I don't know what you know about bats, but they use echolocation. They communicate in ultrasonic pitches that most of us cannot hear. If you're a child, and I remember this as a child, you can hear them, usually as clicks. Now here, where I live, North America, particularly the East Coast, most of what we get around here are little brown bats, and they emit frequencies, for the most part, are well above our human capacity to hear them. Typically, an adult can hear somewhere, up to around 15 kilohertz, give or take, depending on you. My hearing is quite a bit worse than that. I don't go much above 10 now. I used to be able to hear 18. The ultrasonic security systems of days of old used to drive me absolutely, well, batty. But anyhow, this is a device that converts that high frequency, which most of us can't hear, into a lower one. I'll get into the method of how it does that later, but for now, I don't have any bats handy, so I can't show you what that sounds like. I do have recordings of it. Again, more on that later. I'm not going to produce them here. It's just too long, too much. But the bat calls, as you hear them, they fly around. Usually, most of the time, I catch good ones late in summer. Late August, September, when there's a lot of insects around. When that's what they're feeding on, they're harmless for the most part. Little brown bats. They look like flying mice. And the sound they make as it comes through here is sort of a chirp, as they're locating. And you can tell when they get prey because the rate of those chirps increases dramatically. It goes from something like 20 per second to 200 per second. So you could pretty neat. So anyhow, I could demonstrate a little bit about this with other things. Might shed some light on what this thing does. So I'm going to connect this microphone into the unit. Oh, by the way, this is all me. I designed and built this. Get into more about that later. It's got two knobs. One is a power switch, and it's also the volume control. Controls the speaker volume. And yeah, you can turn this thing up loud enough where it will feed back and squeal. The other knob is a tuning. Part of the way this works is the bat calls come into the microphone. Now this microphone, it's not your typical microphone. It's only sensitive to a certain range of audio frequencies, that most of which we can't hear. And this particular one is most sensitive to 23 kilohertz. Most people cannot hear anything 23 kilohertz, or if they do, it's very faint. But this thing hears that like nobody's business. It's a piezoelectric transducer. It can also be used to transmit those frequencies as well as receive them, but it does a really good job of receiving them. In this application, all it's acting as is an ear that can hear that frequency really well. It's sent in, and inside of here there's another oscillator or a frequency source that's close to, and it's adjustable, close to what this thing mostly hears. And through a little bit of electronic magic, it mixes those two frequencies together and plays through the speaker the difference between those two frequencies. So if the difference is say a kilohertz, meaning if there's a 25 or a 23 kilohertz pulse or noise coming in here, and I've got this set to 25 or 24 rather, then the audio coming out here is going to be, out of the speaker, is going to be 1 kilohertz. Well, that's about the center of speech, so we'd all be able to hear that. And the process is called heterodyning, where you mix two frequencies together. Now, when you do heterodyning, when you do that mixing, you end up with both original frequencies. The local oscillator, which let's say is in this case tuned to 24 kilohertz. The incoming signal from this microphone, let's say it's 23 kilohertz. Then you've got a 1 kilohertz signal, which is the difference between the two. Well, you've also got the sum, meaning if you add this local oscillator frequency of 24 kilohertz to what's coming in here, assuming it's 23 kilohertz, well, you get 47 kilohertz. All of those inaudible, meaning frequencies that you can't hear, are filtered out. The only thing this lets come through the speaker is the difference frequency. So that's how this enables us to hear, or get at least an idea of their presence, if nothing else. But whether they're just echolocating with the slow chirps, chip 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 chip, or prey, if they find some prey insect, and they zoom in on it, or if they're landing, they tend to speed up their radar pulses, sonar rather, pulses. Rather interesting. Now, to get an idea of the sensitivity of these things, there's really not much to the electronics in this. There's some magic, but not much. So I'm going to turn him on. Now, I don't know if I'm going to block the light here a little bit. There's a pilot light here. It's got two, I don't know if you can see this, but it's got two LEDs, small. The thing's got two batteries in it. More on that later. This kind of gives an indication if one of the batteries is giving up the ghost and the other one's strong. It does matter some. So he's on. And I've already tuned this for this particular microphone detector. And I'll crank the volume up some. You hear him start to hiss and squeal a little bit. See that? However, the gain on this thing is pretty high for the frequencies that we're interested in. I'm speaking, I'm standing right here speaking, and it's not picking up the pitch of my voice at all, but you may hear some of the fricatives coming through, that kind of thing, S's, and but the letter M, you know, that's nothing. I can rub my hands. You can hear that. Click. Those things contain, those noises contain high frequencies that this microphone is sensitive to. And that this thing is down converting into a lower frequency which we can hear. Again, I don't have any bats handy, and it's kind of early in the season. I may later do another vid where I actually have some bats flying about. I do have recordings, just don't have them handy, and it would take too long anyway. Now here's some keys. I'm going to turn this volume down. Leave it on. You know, it's typical key ring, car keys, house keys, and keys to stuff I don't even know. There's that. Yeah, there's a fair bit of noise. But this thing picks up noises from that kind of thing that we had no idea. I'll crank the volume back up. Get just to the threshold of feeding back, and the slightest, I mean, I'm just going to back off a little bit. It's a little much. Stunning, isn't it? Now, I am indeed, just inches away from this pickup microphone. I'm going to move, oh gosh, let's call it 8 feet away from here with my keys. And check this out. Yeah, like that. Thing's got a ton of gain. So, you know, you sit out on the deck with this at night, aimed at the sky in that country, and you'll hear them all over the place. Get rid of the keys. Okay. This has the capacity to hear, depending on which microphone I use, anywhere from 15 to 60 kilohertz. Now the bats, some of them, especially in some different places, do extend beyond those ranges, particularly upwards of 80 kilohertz. But these little brown bats that are around here, they stay pretty well behaved. I catch them usually with this particular detector. It's most, as I said, most sensitive to 23 kilohertz. There is a curve to that. It is not sensitive only to 23 kilohertz, but that's where its peak sensitivity is. It's got two ranges. As I said, this can go from 15 to 60 kilohertz in two ranges. It's a range switch here. In range 1, this dials from 15 to 30, and in range 2, the higher range, it dials from 30 to 60. Just a convenient way to do it and not have a whole lot of sensitivity on this adjustment. Volume, you know, typical, nothing special about that. So disconnect our microphone here. Get rid of this. Okay, what's inside? I'll tell you, precious little. That's the circuit. Let me see if I got a good focus on it. Maybe zoom in a little. Okay. I said it runs on two 9-volt batteries. It will also go. It can be operated on a single DC supply anywhere from 12 to 22 volts. This was convenient just for portability. It uses a split supply, plus and minus, anywhere. It'll work from anywhere from plus and minus 6 to 11 volts. So 9, 2 times 18, just great. The heart and lungs of this guy is this IC here. It is a oh gosh, balanced mixer. Balanced mixer. 8630 is the part number. Basically, what this does, takes two signals in, mixes them together, and will give you the product, or the difference, or the sum of the difference, plus the two original frequencies out. And you filter out what you don't want. That's what some of this stuff, this network here is. And you amplify what you do want. This is the local oscillator. It is a CD4047A. It's pretty vintage integrated circuit. It actually is for a 14-pin dip, a ceramic part with a metal lid. Those are so rare. I put it in here just for artistic purposes. I've got plastic modern parts I could have used, but it just looks so pretty in there like that. That's a local oscillator, and that's what's tuned by that control. It controls the frequency of this, that this sends to him, which he is mixing with what's coming in the microphone. What's coming in the microphone is amplified quite a bit. This is an op amp, a signal amplifier. Weak thing comes in, stronger thing goes out. In this case, an LF356 National Semiconductor. Not much here, just a coupling cap, gain setting resistors. I think, actually I'm looking at the schematic, yeah, the input resistors 10K, it's an inverting amp. The output resistors 10 meg, you get the idea. Pretty smart gain there. Couple of offset trim pots for this guy. Really wasn't necessary, but I had them, I just put them in. Power supply. This is where the power from the batteries is split and filtered somewhat, decoupled is a better word. LED drive resistors. This is an LM380. It's an amplifier, an audio amplifier. It takes whatever comes from this guy's output and drives a speaker. Decoupling cap for him, a coupling cap for the speaker. Almost every component I used here, the chassis, well, except for the batteries obviously, but the chassis, almost all of the components used in this thing are recycled, reused, hoarded, squirreled away, except for this part, this circuit board, and these two pots, which were new, but I had them handy. I did not buy these. But yeah, it's almost completely recycled junk. These nice nifty caps, and I tend to go through and pick the ones that match color-wise or size, manufacturer, that kind of thing. May have noticed this. It's pretty colorful. A couple of regular old pots. One's got a dual switch on it to switch in and out the batteries, power switch. Little 3-inch speaker here, 0.65 watts, although the audio amp in this thing, it can put out, I think it's a watt or two, I think 1 watt, and it'll do it too until you blow the lid off it. Probably a little bit more for this speaker than this is designed for, but just be careful, and I'll find another one if this one pops. So pretty much that's it. This is an aluminum grill salvaged from an old Newtone intercom of old, something I used to work on. Speaker probably out of a table radio, something like that. Obviously the chassis used to be a Radiac, and it also has two outputs. This one You can connect a frequency counter too if you really want to know what frequency exactly you've dialed in. It could be helpful if you're trying to actually analyze or determine what the frequencies you were hearing were coming from the bats. Another output is just a line level audio out suitable for recording purposes. You plug it into your typical old cassette deck, which I still use, or right into the line in of your computer to record that way. And the two of the information both of these combined could give you fairly accurate representation of what the bat's frequency they're outputting actually is. So like a pretty nifty little sort of fairly moisture tight watch for the speaker, moisture tight, portable, lightweight, this thing hardly weighs anything, Batbox, bat detector. Well, a lot of people seem to enjoy fiddling around with this. Now, the schematic, well, I have to do a better job of reproducing this, but that is it. It's a hand-drawn. That's actually a photocopy of my original, which was on green paper for some reason, which didn't show up as well. And plus, there's a couple of notes on this I made for some guys that wanted to build, make their own version of it. And by the by, there's a part of this that I need to give a bit of props about. The microphone. Of course, now I can't. Oh, there it is. The microphone. Leave the schematic on there, maybe if it's possible to see it at all. The microphone, I got this particular one. I'm not sure exactly. I don't remember what it was he had made this particular probe for, this particular microphone for. But this was made by an associate and dear friend of mine, very bright guy. Somewhere he got these 23 kilohertz transducers, microphones, and he built this housing for it. You know, it's RG58. Odd that he used an XLR connector. I think it was because, well, for two reasons. It is sort of a microphone. It's a 3-pin XLR, but I think mostly it's because this is a piece of steel conduit that he used as a housing. Very, very nice. Foam, and managed to get this transducer to fit centered and fairly tight in there. And the way this connector here mates up with the diameter of this is just, well, couldn't get better than that. Very rugged, never had a problem with it. But going XLR to BNC, I always teased him about that, but daggone it, the thing works, and it's the best mic I have for the thing. And so kudos to Mr. Smith. And geez, I hope you can see that. Anybody wants to fiddle with it, you know, build all you want. Nothing proprietary here. No patents.